Hey, what's up guys? Welcome to another MeTTa tutorial. And in this tutorial, we're going to learn how to work with our console and also use that to do some debugging in MeTTa. Okay, so first thing we need to understand about MeTTa here is that all values obtained during evaluation in MeTTa are collected together and then they will be returned after the execution of a program has completed. So this means that the whole program can be treated as a function that returns a value. So we all know that values being returned in functions are typically returned at the end of the execution of a function. So yeah. Okay. If we are using the MeTTa CLI for running code, or the MeTTa CLI code runner, or we are using the REPL for MeTTa, results are going to be printed at the end. However, this is not true when we are using MeTTa through its API. Okay, so if this is the case, then how do we log outputs as the program is in execution? So we have two functions that enable us to do just that. These two functions are called println with an exclamation mark and trace also with an exclamation mark at the end. Okay, let's start by seeing what println does. Println is a function that accepts a single value and it outputs that single value to the console of our application. Basically, it sends the value we pass to it to our console. So if I say println hello, then hello is going to be sent to my console. Let's run this code, and as we can see, hello will be printed to our console. Okay, so println accepts a single value doesn't mean that we cannot pass multiple values to it. We can accommodate for that case by using parentheses. So if I want to say hello world exclamation mark, I could just surround the two words in a parenthesis, then they would be sent to our console as such. Okay, so one thing we need to understand about println is that, as I've mentioned earlier, every output in MeTTa that is going to be evaluated is collected first, then returned at the end of execution. I'll show you what that means right now. But what we need to understand is, when using println, the values that we send to the console are first going to be sent before the outputs that are collected are being printed. So what I mean is, let's say I have a relationship that says is gentleman A, and another relationship is lady B, and also let's add another relationship for lady. Let's say C is also a lady, A is a gentleman, B is a lady. Okay, so if I wanted to pattern match the output by saying what I want to say is, I want to output this to my console by evaluating it. So I want to pattern match by saying gentleman A, then let me just output A over here, and after that let me print the reduced output of self, but now let me output lady in this case, not A. I want to hold this on variables. Let me fix this quickly. X, so lady X, and let's output X. But to differentiate these, let's say here, let's add lady. Let me just wrap it in a parenthesis, lady. So it would look like this. Okay, so this is going to be X. Let's also replace this with let's also replace it with gentleman X. So now what we expect is this print println statement to precede the output of this reduction. Let me comment out this these two lines up there. And since I've said that println precedes the output of any reductions performed in MeTTa, so what we expect is this print statement being sent before this output is being sent. So if we run this MeTTa code, what we get is lady C and lady B first being sent to our console, and gentleman being sent afterwards. So this is going to be helpful when we are debugging and we want to investigate values of variables at runtime, instead of waiting for the output at the end of the execution of the program as such. So now reversing these, changing these places would also not matter, since the println statements come first in every case. So we see that ladies B and C come first and gentleman A comes next. So it's a clever way of saying ladies first. Okay, let's move on. So now that we have seen what println does, let's see what trace does and how we can use trace to send output to our console. Okay, so trace is a function that accepts two arguments actually. The first of which is going to be the thing that we want to send to the console, while the second argument is the thing that we want to return, or the output that we want to return. So you can imagine something like this being used with trace. So the first argument is going to be the statement or the thing that we want to print to our console. So let me define a function first, then I will call trace in that function. So let's define a function that is called isGentleman. isGentleman is going to be a predicate that accepts a single argument and matches the space to check that if it is true. So if this matches, I'm simply going to return true. Now if I run isGentleman on A, I expect to get true, but first let me comment out this output first. So as we expected, the output is going to be true. So now I'm going to use trace instead here now. So the use case of trace is to output first. The first argument of trace is going to be the one that we want to print out, and the second argument is going to be the output that is expected to be returned. So what we can do is pass these pieces of information to trace. So I can say input x to signify that the input of my function is x, the value is x, and as the second argument I can pass the statement that needs to be reduced and returned. So yeah, is gentleman is the pattern I want to match against. And if this is true, then I'm going to return true. And while I'm at it, let me just make it cleaner and format it. So let me just say output and paste the match statement in here. So now what we expect to get from this is input A and output true. So you can see using this in debugging functions that you are interested in investigating. So yeah, let's see the output of this function. And at the end we get input A. For input A, there is output true. What if we replaced this by B? We see that input B has no output, since there is no such knowledge in the atom space that I have declared before. So this is how we use trace. Now let us take the example of defining a function, specifically the factorial function, and see how we could use existing knowledge to debug our way into the definition of the function. So let me write the function signature first. So factorial, and the value I need to pass is going to be x, rather let me call it num for this case. And okay, so we need to write two different cases for the factorial. First one is going to be the base case, and the base case for a factorial is when num is 0. So I'm just going to do that, and I'm using an if expression. When equals num 0, then the then statement is going to be over here. I will return 1, and then in the recursive case, this is the base case, this one is the base case, and in the recursive case I'm going to do the recursive case. So recursive case. So okay, now I want to check the values as they change during execution. So I want to see every value num goes through. So as you know, we're going to decrement num by 1 on every recursive call. So I want to log out that value and also the current value. So to do that, I can use the let star expression. Let me just remove this one from here. And if you remember, I stated that the inputs to a let star are the first one is going to be the consecutive substitutions glued together. So I'm just going to do that here, and at the bottom is going to be the result or the output I'm going to use the recursive substitutions for. So here I'm going to compute the next number, the next step, the next number I'm going to use for the next step. So it's going to be num minus 1, the decremented value, and so my result is also going to be computed here. So what I need to do with my result, or basically call the recursive case on, is multiply num by next. So this is what I do. Now I can print this output to my console and see as the execution goes on. So what I need to do is write these down in an informative way. Let me just say next is next, and current is num and result is result. I need to remove this $sign from here, and after this I don't need the parentheses at the end, so I can just return result. So now if I call factorial of say 5, I should be able to see the printed out values as the function progresses recursively. Okay, so let me check if any code is uncommented. Yeah, everything is commented, so I can proceed. Okay, let's run it. And I see some kind of error here. Oh yeah, I don't have current defined, so this remains here. So the rest are correct. Next is 4, result is 20. Yeah, so what I need to do is remove this $sign from current. Now as you can see, I get the value. Next is 4, current is 5, result is 20. Okay, cool. What I need to do now is call the function factorial on next. This is the recursive case, recursive call. So now I should get the values printed. Okay, the error says unexpected of end of expression, so this means that there is a parenthesis that needs to be closed but is missing a closing parenthesis. Let me check it for now. This one. Okay, yeah, it's over here. I need to close this. Yeah, I should be good to go now. Yeah, so now as you can see, maybe I didn't structure them in a logical way. Let me just do that once. It would be better if I put current first, then next to the current. So yeah, let me clear my console and run. Now current is 1, next is 0, result is 1. Current is 2, next is 1, result is 2, as we expect. Current is 3, next is 2, result is 6, and so on and so on. And finally I get the output of my function factorial. So as a quick recap, we have seen in this tutorial how we can use the println function and also the trace function, and how we can use them to debug our functions. And we've seen how we can also define a factorial function and debug our way into its definition. So this is it for this tutorial. See you on the next one.